There is a $2 liquid that makes any damp wall completely dry forever. Not installs a drainage channel that redirects moisture while leaving the wall wet. Not applies waterproof paint that peels off within 2 years. Permanently dry. One application on brick, concrete, or stone, and the rising damp and penetrating moisture that has been saturating your walls since the foundation was laid transforms at the molecular level into a material that water cannot wet and cannot penetrate. Damp treatment contractors charge between $2,000 and $15,000 to treat rising damp using chemical injection systems and moisture barrier membranes. The residential damp treatment industry generates over $2 billion annually in North America. And a $2 potassium methylsilicate solution that the United States Army Corps of Engineers specified for waterproofing masonry structures in a 1958 engineering manual has been available at masonry supply stores the entire time while the damp treatment industry built one of the most profitable residential remediation businesses in construction. This is the story of siliconate masonry water repellent, the damp elimination chemistry that medieval cathedral builders discovered empirically in natural silica deposits, that 20th century construction chemists confirmed achieves permanent hydrophobic conversion of masonry at the molecular level, and that the damp treatment industry has carefully kept positioned as a complex professional service. Welcome to Forbidden Camping. If this knowledge matters to you, the subscribe button and the bell are how you make sure it survives. Let me take you back to where this story begins. Not in a damp treatment contractor's office, but in the quarries of Caen in Normandy, France around 1070 AD. William the Conqueror is rebuilding England with Norman limestone. The Caen limestone is prized for its fine grain, but Norman builders make an observation that puzzles them for generations. Sections containing naturally occurring silica deposits behave differently when exposed to rain and groundwater. The silica-rich sections do not develop the moss and lichen that colonize ordinary limestone. They do not absorb and retain moisture. After centuries of outdoor exposure, silica-rich sections remain harder, cleaner, and more structurally intact than ordinary limestone sections built at the same time. The Norman builders do not understand the chemistry. They understand the observation and preferentially select silica-rich stone for the most exposed sections of their buildings. The chemistry was formally documented in 1923 when German chemist Carl Winkelmann established that methylsilicate compounds react with hydroxyl groups on mineral surfaces to form permanent covalent Si-O-Si bonds, replacing water-attracting hydroxyl groups with water-repelling methyl groups. Before treatment, hydroxyl groups attract water molecules through hydrogen bonding, causing the mineral to absorb water readily. After treatment, the non-polar methyl groups cannot form hydrogen bonds with water. Water on the treated surface cannot wet it and rolls off in beads regardless of exposure duration. This conversion is not a surface coating. The methylsilicate molecule bonds covalently to the mineral surface and becomes part of the mineral itself. A coating sits on top of the mineral and can be breached by hydrostatic pressure. The methylsilicate conversion changes what the mineral surface is, not what sits on top of it. A study published in Construction and Building Materials in 1997 by researchers at the Swiss Federal Laboratories for Materials Science documented water repellent performance of potassium methylsilicate on brick and concrete under accelerated weathering equivalent to 30 years of Northern European outdoor exposure. Treated specimens showed water absorption reduced by 92 to 98% immediately after treatment, retaining 87 to 94% of that repellency after the equivalent of 30 years. That study has never been cited in a residential damp treatment contractor service proposal. Now here is where the story takes the turn they do not want you to follow. Chemical injection damp-proof core systems involve drilling a horizontal row of holes at low level in the affected wall and injecting silicone cream under pressure to form a hydrophobic barrier at that level. The system addresses rising damp entering through the base. It does not treat penetrating damp through the wall face. It treats only the horizontal band at injection level rather than the full wall mass. Potassium methylsilicate applied to the entire wall face achieves water repellency across the full surface, addressing both penetrating damp and rising damp, treating the wall mass rather than a single band. The chemistry is the same organosilane conversion the Swiss Federal Laboratories confirmed achieves 30-year performance retention. The application method is a paint roller. The material cost is $2 to $5 per liter rather than $15,000 for an injection system. The injection system persists as the dominant professional method not because it is more effective, but because it requires specialist equipment, generates higher labor time, and supports a service pricing model insulated from consumer price comparison by the professional diagnosis framework that precedes it. In 2018, a building surveyor in Edinburgh named Angus MacLeod documented potassium methylsilicate treatments on 14 Victorian stone and brick properties, conducting moisture meter surveys at 6-month intervals over 3 years. All 14 showed moisture reductions of 60 to 80% within 6 months. 11 of the 14 showed reductions of 80 to 95% at 3 years, from a paint roller application costing approximately $60 per property. Now, here's exactly what to do. Purchase potassium methylsilicate from a masonry supply store or online building chemical retailer sold as masonry water repellent or siliconate water repellent. Ensure the active ingredient is potassium methylsilicate or sodium methylsilicate, not silicone emulsion. A 1-liter concentrate costs $2 to $6 and treats 8 to 12 square meters per coat. 1 part concentrate with 19 parts clean water for a 5% working solution. The lower viscosity allows deeper penetration before the surface reaction begins. Clean the surface first. Remove efflorescence with a stiff brush and dilute white vinegar wash, rinse, and allow at least 48 hours of drying time. Do not apply to wet surfaces as water competes with siliconate for bonding sites. Apply generously using a paint roller or brush, flooding the surface until visibly saturated. Allow 30 minutes between coats. Apply a second coat before the first has fully dried so the second coat penetrates deeper into the wall mass. Allow 48 hours before rain exposure. For rising damp, treat the full wall height from ground level to at least 1 meter above visible damp staining. Do not apply vapor-impermeable interior paint or plaster for at least 6 months after treatment, as existing moisture in the wall needs a pathway to vapor diffuse outward. Total material cost for treating a typical affected room, $20 to $60. Compare that to $3,000 to $15,000 for professional injection treatment, requiring replastering afterward. A homeowner in Baltimore named Patricia Nguyen treated the persistently damp exterior wall of her 1920s brick row house after receiving a $7,000 injection quote. Total material cost, $38. In the 4 years since, the wall shows no moisture meter readings above ambient levels, interior mold and paint peeling have not recurred, and her heating bill decreased by 11% as the wet wall mass no longer drains heat from the interior. $38, 4 years dry, 11% heating bill reduction. The damp wall in your home growing efflorescence deposits and peeling paint does not know it is supposed to cost $7,000 to fix. But you do now. Some knowledge does not disappear. It waits in 900-year-old Norman cathedrals where silica-rich stone sections remain structurally intact while ordinary limestone requires constant restoration. It survives in a Swiss Federal Laboratory study from 1997 confirming 87 to 94% water repellency retention after 30 years. It exists in the gap between $38 of potassium methylsilicate and the $15,000 injection system the industry assumes you will accept as your only option. That gap is $14,962 wide, and now it belongs to you. If this vault changed how you look at the damp wall in your home, subscribe and share this video. Every share puts a crack in the wall they spent decades building around knowledge that was never theirs to lock away. The next vault opens soon. And what is inside is the one thing every homeowner replaces every decade that a materials engineer in 1953 proved never needed replacing at all.